And we are live. Hello everyone. It's been a little while. Okay, so today's plan is to make kind of a slow motion lightning effect using simulation nodes. Now this will take a few detours before we get to that destination, because I have a couple of tests that I want to do along the way. But here's the plan. The plan is to have a point to just start off with, so I'm just going to go and have one vertex in the middle. I could just do this with geonodes, but just to demonstrate. I want the point to keep moving up and up without a trail. We'll add that in later. But at certain points it'll split, and then it'll keep going, and then it'll keep splitting more and more and more, to kind of simulate how lightning works, but in a very slow-mo style. Now, one reference that I'm pulling from that I really should have rewatched before I started the stream, is from Thor Ragnarok. In one scene, he's jumping down onto a bridge, and there's slow-mo lightning everywhere, and you can see the lightning splitting in the trails and everything. It looked amazing. I really should have rewatched that, but it's fine. Okay, so let's see, we need a simulation zone. Maybe I'll rewatch it when we get to the stylization part. Now it's time for logic. So there's a few things that we'll need for this kind of thing to get set up. So to get started off, I want to have a velocity setup. Or do I even need velocity? Yeah, I need a velocity setup for this. So let me move this over. I need to just enable a few things. Floor, just so that we have a general scale of everything. Origins, yeah, that's fine. So we're going to need some velocity for when the particle's moving, and then we'll need to apply that velocity. Simple stuff, what I do every single time. So, wait, no, named attribute, this will be vel for velocity. We go put that in there, connect that to there. You will see that I'm using 4.0 for this, but this will probably all work in 3.6. Oh, and I have to remind you all, when 3.6.1 comes out, download it. Upgrade to 3.6.1. Because there are a few bugs in 3.6 that are very annoying to deal with, particularly with UV pinning. And where if you have like a mirror modifier with bisect enabled and you apply it, it'll pin your UV maps, which I have found to be really annoying, and some other bugs. But upgrade to 3.6.1 to have a better life. But yeah, with that out of the way. So yeah, this part. I'm just going to get it so that the particle moves up at a constant rate. So I'll use an add node to make sure it goes up by a little bit. So we should see particle goes up. But the thing is, I want it so that we can manipulate this velocity, but always have it going on a constant speed, or speed I decide. So to do that, we use a normalize node. Now this will make it so that it always goes at 1 or negative, well, essentially, it'll keep going at a same distance no matter what. In this case, 1, in any direction. And then we scale this down to whatever we so choose. So here we can see that this is essentially doing gravity at the moment, but when I hook this up and put it at a much lower level, we should see that this will move at only 0.1, and it will stay that way. So this means that we can change directions while still going at the same speed. So I'll increase this to 0.5, there we go. So we can change directions, but speed is the same, which is good. That'll help us quite a bit in the future. So there we go. Let's do that. This is our, I should label a bit of this. So this is speed. And this one is apply velocity. Velocity. There we go. So we have that. That's the basic logic of it. Now we need to get a few other things going. So I'm wondering how to do this properly. But essentially, I want a randomization for every single frame for where this particle is moving, so that when the split happens, the two particles will move away from each other. So if I use a random value node, let's set this to vector, and we plug this into here. Now, let's make this, because this is more of a direction, actually. Yeah, how should I do this? because I need to think about how we'll mix this going forward. I'll do 0.1 and negative 0.1. But we need this to update every single frame. So if we use the scene time frame, the seed will update every single time. Now we can see that that's just going berserk, which is good to a degree, but I want it so that it keeps going up. There we go. So we can see particle is going up, which is nice. Hope you're having a great day. I am. Today was a very productive day. Very good day. Okay, so now that we have this, let's implement the splitting factor. So to do that, I'm going to use a duplicate. There we go. Duplicate elements node. So we'll split off the branch and use a duplicate. Now, I'm not going to actually duplicate the points. I'm going to separate it, but only keep that new point essentially if the thing is set to true. And then I'll join it into the fold because I want the original geometry to remain unchanged. And it's kind of simpler this way. So we'll just only add a new point. And what if we want multiple splits? So 1, 2 splits, 3 splits, and so on. So I'll do that. If I do this, we'll see that things start to go downhill very fast, which means that I need to go and implement a failsafe. Because as we can see, since this is exponential, it'll keep doubling every single frame. And I should probably change this to 30 frames per second because of the stream. But since this is exponential, right now we probably have like 100,000 points. Next frame, it will be a lot more because it's doubling every single time. Rather than just, you know, doing other things. So for the failsafe, I'll say if it goes above 100,000 points, then delete everything. So delete geometry, which will use the domain size. If the point count gets greater than, and I'll put in 100,000, then delete everything. So let's put this here. I'll hide everything else. So this is failsafe. Is that the right word for it? Failsafe. Yeah, it's not exactly the right definition, but it gets the job done. If it becomes too much, boom, it gets deleted, sparing my computer from explosions. But that's very important so that you don't fry your computer. Or just, you know, make it lag out and crash. So I'm going to use a random value node. In this case, I'll use just an integer so that it'll go in between 0 and 1, but then we can make it so that it splits multiple times if we so choose. I think I'll keep it at 0 or 1 for now, but there we go. And then I want this to be updated every single frame, so seed goes into there. Now we should see that it is not working as intended. Something is wrong. Seed and ID. Is the ID wrong? Index? 0. Split is 0. Yeah, we see that works if the amount is 0. So it seems like they all might be sharing the same ID, which could be really, really bad. That could be extremely bad. Set ID? Huh. Index? I'm a little worried about that. Because that Boolean? Mount. Seems like that started working, but then it forgot to. Here, let's set this to like 0.01. Oh no, okay, it was working, never mind. It's just because, okay. So I need to set this up in a different way. So it'll only happen at a probability of 0.1, so that's better. Okay, so we can change the rate of splitting, but then we can change how many times it splits as well. So, okay, this is a better setup for it. So we can change the probability of a split occurring. That's good. I'm okay with that. So here we can see it keeps doing that until that happens. Okay, good, 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 good. And now, since we have that, we need to think of other cool implementations for it. But maybe we should start seeing the trail. So let's set up the trail. So I'll label this split. There we go. So for the trail, this will be good. I'll have a new geometry nodes object. So this will be points, or lightning points, I guess. Lightning points. Yeah, and then we'll have lightning trail as another one. So lightning trail. Here we are. So now that we have lightning trail here, let's go and make the trail. So we'll need a simulation zone right here. Plug that into there. But then we need something else. Something better. We need to use the current lightning points object, and then we'll need to join that into the simulation. So geometry, join geometry. And I'm going to disable the caches for both of these. The cache, I think, is still a bit bugged, but since we have no pre-existing geometry at the moment, it should be fine. But here we can see, since it's being joined every single time, we're getting this happening, which is very cool. But I think we need to make a new system for the orientation, because I think this is still a little not that great. It needs some editing to it. But we can see that the lightning trail is working pretty much as intended. We'll just need a few fixes. And also, we'll need to make the trail for it. So if we extrude on the vertices, we can plug in the velocity, which means that we will now get trails and set the offset to -1. There we go. So there we go. That's a very simple way of making trails on points if you have velocity, of course. So there's that. To make this more efficient in terms of speed, you can make this into an instance. So it'll treat every single frame of the trail as one object and then join them together, which, as we can see, is quite a bit more performance than just having that there. So this part is optional, but recommended. Like, when we get to like meshing and shading and all that, we may need to change that, but this is just to make a basic trail just to start out. So this is trail. Here we go. So that's good for now. Now let's go and mess around with the points. Yeah. Okay, so I want to edit the velocity mixing for this. So, okay. So currently we have the random value node and the velocity, but I want to mix them. But we have a slight little issue. How do we mix these values if this value changes because of the 0.5 value? How do we mix the rotations of the vectors? Well, if we normalize them before the mixture, it should be fine. So if we normalize both of these, and then we mix them, it should mix their orientations better. And then we normalize it after the fact, just because mixing between 2 points will lead to some loss. That's just to keep it so that the speed is constant. So here we should be able to see, if I bias it almost entirely towards the old velocity, we should see a much more gradual splitting and such, which I really like. There we go. So we have a ton of points moving, and that's nice. But if we bias it almost entirely towards the randomness, we should see something a lot more erratic. There we go. So I need to find which one will be better, because I do really like this version, but that's not really giving a lightning feel. We could also change this mixing dynamically using like an age parameter, which I should probably go and create. So yeah, let's go and make that. So some new data is needed. I'll do this after the velocity. So there we go. So let's store named attribute. This will be age. And the age will keep going up by 1 every single frame. So every single time the simulation updates. Looks like fungi growing. It could. It's a growth simulation. And lightning grows in a way. Let's see. So here we have the age. That's the simple node setup for having an age parameter that goes up every single frame. It's very nice, very convenient. Now I want to make it so that these particles will die based on a lifetime parameter that we give them. So to do that, we use delete geometry, and if we use a thing of logic that says if the age is greater than certain value that we give it, so I can make it so that they'll last 10 frames and then self-destruct. We do that, and then boom, they're dead. The trail survives, but they're dead. Okay, so we do that, but I want to set a lifetime parameter. So for the initial start mesh, I'm going to set a initial lifetime value, and this could be an integer. I'll just have it because, you know, scrolling will be easier. In this case, I'll have 200 for that. So if we go back over to here, I have a named attribute for the lifetime. There we go, attributes. That means that once the age gets more than the lifetime, it will delete, killing it. So, death, I guess. So the failsafe, just in case the poly count gets too much, and then just age, death, all that good stuff. And then lifetime right here. And also, I have the failsafe inside the simulation, because if we put it outside, then the calculation for all those particles will still happen. Just the deletion will happen in post. So make sure you have it inside the simulation loop. And another reason why I have the lifetime here is because I may want to decrease the lifetime for the duplicates, which may look very cool. I'm not entirely sure, but I want to at least try it out. So there we go. We have that, and they should delete at 200. Did I have it? I had it, yes, at 200. So there we go. There we go, and actually, wait a second. That's going up a bit faster than I anticipated. Oh no, that's because of the 100,000 thing. So I'm going to decrease the amounts. I also, I want to try something else. Now this will be a little bit different than what I normally do. But maybe I'll have another mix factor. So let's do another mix. I'm going to mix between current velocity, but also between the vector that is to its neighbor. So the points will either try to attract or repel from each other. So if we get the index of nearest, which is a very nice node, I'm very happy they added that. And then we use an evaluate at index. Let's set this to vector. We can get the position, need to say that right, of the point's nearest neighbor. So if we do that, we now have the position, but then we need to get the vector to that position. So we just subtract from the point's own position, which I could separate these to make it a little clearer. So this will be vector to neighbor. So vector to neighbor. Oop, neighbor, there we go. And now if we connect that into here, I'm not sure if this will attract or repel. I may need to flip those around. But now we should see. This one is the attraction one. Interesting. Very interesting. Now, if we bias this almost entirely towards avoid your neighbor, or this one is be attracted to your neighbor, it does that. But if we want a repulsion factor, we should see... Oh, that is... Oh, wow, that is cool. Wow. Okay. So we can see that it takes a little while for it to actually happen. I'm assuming that's because they technically spawn in the same place. They just need a little bit of motivation to get moving. So I can actually add in a little bit of randomization to this, to the position here, so that they have a little bit of motivation to move away. So I'm going to try that. This just needs to be an extremely small random value. So I'll just scale this down by a lot. By a very little amount, just so that it's reading, oh, it's slightly different. Oh wow, no, actually, it was fine. Huh. I'm surprised, but not disappointed. Okay, that's fine. Now let's bias it so that, you know, it's a more reasonable amount. They still tried to separate from... I'm not sure if this is going to be a lightning effect anymore. And also, it seems that the splitting is still happening way too much. Which I could make it so that the domain size, like how many points there are in the scene, will determine how many splits will happen. But we'll see. We'll see. Now that's pretty cool. I'm going to set this to 0.01. I'm a little worried that it'll take, yeah, it's taking quite a while for one split to happen. Well, when they start, as we can see, they just keep going. I'm going to set the lifetime to be 500. Okay. Come on, you can do it. I also want to add like a split value to the particles that get split, so that... Oh, there it goes. It's so incredibly interesting. Let's try the attraction one again. So here's it attracting. So all of them are trying to go closer to their neighbor. Splitting is happening so much. Yeah, okay. Looks like we may need the domain size. If we take that and we divide it like that by that, we may get a good... Nope. Actually, we can see that splitting less as time goes on. So if I set that to 100... Oh, wait. No. We set it to 1. That's a more reasonable value. And we can see how they're kind of orbiting each other, which is beautiful, as they go along. If I make it so that, you know, they try attracting above all else, you can see that that is occurring. That's cool. I like that. But I do think the splitting is better, unfortunately. Because here, it's like, oh, they are trying to avoid each other. And if we look at this from the top, you can see that it's almost like a, oh, that's cool, seeing how the particles are trying to avoid each other. Now, if I increase this by a lot, we should see... That's an interesting way to view it. Because the speeds are all the same, and I can make it so that they have different speeds. Randomized speeds per index. So let's plug in a random value between 0.1 and 0. Maybe that was a bit much. No, let's say 0.05 and 0.01. Let's see how that works, and let's re-enable the trails, just so that's easier. It's more like plant growth. This has turned from lightning into something else. I apologize, but this is very fun. Oh. And I could make it so that this, like the points are extruding from a line so that both of the trail and the points are one. But I think I'm good with this because it kind of simplifies things. Actually, that does kind of look like lightning still. I randomize the output a bit more. It's like that. Like, the repulsion factor doesn't have to be a thing. Even though... It's all about finding that good middle ground for all this. Okay, 0.2... Actually, that is looking like lightning. Now, if I have no kind of collisions or anything like that, that still looks like lightning, but I do kind of like the go away from each other incentive. Like that, not great. Like here we can see the splitting is happening. I kind of wish that the split was happening more with the duplicate rather than the other way around. But I want to add in some more data just to see what happens. So I'm going to put this part in here as well. That's for the split probability. This part may be getting a lot bigger than I kind of want it to be, but it's cool. We're experimenting. So I'm going to make another value. So this will be splits for the split counter. So this means that every time a split goes through, it's kind of like the age parameter, but for splitting. Every time it goes through here, 1 will be added to the split count. There we go. So, let's see. So now that we have this, we can make it so that the deviation factor is even more with the amount of splits that happens. So if we get that attribute, in this case, splits. Why are there two? I'm a little worried about that. Splits. They're spelled the same, I think. If we use then a map range, we can determine which ones try to move away from the other. So, the more splits that happen, by the fourth, it will try its hardest to move away from the other. And we can see that is happening for quite a few of them. I don't want any of them to be quite that high. Actually, I'm going to turn off the weighted distribution so that we can see it in full. Well, we can kind of see it. Actually, okay. Let's set this to like 10 and then 1, so that once it gets to 10 splits, which I don't think will be long given this thing's history. Yeah, we can see it, but it's a bit less than I was hoping for in terms of its prevalence. Let's re-enable the weighted split. So this means that the original particle that all of them came from will not split. Or, will not move away. It'll keep going on its course. While the other ones will become more and more deviated, trying to move away from the center. And actually, I should showcase that. So let's disable the move away from your neighbor, and put this into mix with random. So here, we will see that the more splits happen, the more random the thing becomes. Which evidently, there's not enough of those happening, so I'm going to set this to 0.01. Or 0.05, so that we can see this. There we go. So the more splits happen, the more and more random they become. In this case, there are so many splits that are happening that, as we can see, that occurs. There we go. So let's go back and apply the move away from your neighbor thing again. again, I'm not sure we need that. The results are not as good as I would have hoped. But that's the thing about this kind of math. It's there. You can't entirely predict it because our brains are too small for that kind of math. So, yeah, that's fine. And we can see the map here. Interesting. Now I could also make it so that it's weighted less depending on the distance from it. But I think this is fine. I think we can keep it at, what was it, 0.2 before? When the split happens, they do try to move away from the center, leading to that happening. It is causing an actual split. I could probably, like, simulate the splitting without it having to find the neighbor by getting the tangent and saying, because we can see here, it's moving along a path, and then it decides to go out that way, and then do some random stuff. Well, anyway, I think it's time for me to implement the actual trail with, you know, with a mesh that we can view and see what's happening. So this was a nice, you know, initial trail thing, but we need to do something different in order to have an actual viewable mesh. So to do that, how do I want to set this up? So I'm going to make a simple, I could make this procedurally, but I think we're fine as is. So I'm just going to make a simple crisscross mesh like this. Now I need it to be like this so that, you know, the center point is where it starts, and then that point will be where the end of the trail will be. I can scale this down to like 0.1 is fine. I'll move it, actually I want to scale by 0.5 so that it will be 1 meter in length. That's one gripe I have about Blender. The primitives are all scaled to 2 meters. I think if they were scaled to 1, it would be better. Like the default cube is currently as tall as a human. I think that's a little bit much. Just a little anecdote right there. Now, I can't apply a material to this to make it so that it works in here because materials do not work with simulation nodes at the time being. That was broken, that was changed in the beta because the devs decided to redo the material system under the hood, and they couldn't fix it for the 3.6 release. But wait a second, I'm in 4.0 at the moment. I'll test that later. But yeah, we want to instance our little plane here, our little trail mesh on there. So let's go to there, do that, and if we take a look right now, we see that it appears, but we need to make the scale and the orientation correct. So for the orientation, we use an align Euler to vector node. We plug this into the vector, and we set this to z. We should see, there we go. Now all of these are facing in that direction, which is good. For the scale, we need to get the length of the vector, or the velocity, length. There we go. And then we use a combine x, y, z, because we only want this to affect the z-axis. The other two will be fine. So let's set this to 0.1 for the rest. Or, actually, probably, words today are a little difficult. Today was a busy day. Yeah, here we go. So there we go. 0.1 I think is good, and we can see that there's a trail for 1 frame. Now what we want to do, let's go and put that into the frame. We want to join this into there, but I think we may want to convert the instances to geometry using the realize instances node, and then change them back into instances just for speed. That's the speed increaser that we had before. So let's go and connect that into there. Let's move that out of the way. So this will be optimization. There we go. So that just makes it so that every single part of the trail is treated as one object, making it a lot faster for this simulation and us. So now that we have that, that's good. We can now go and change the shading, but I have to set the material after the simulation because those do not like working if it's on the mesh domain. In 3.6, but then again, I do have to see if that works in 4.0, but I'll check that later. This will work, all this will work in 3.6, but I'm in 4.0 just because I forgot. So this will be trail mesh. There we go. Okay, that's fine. Yep, all that seems to be good. So in the shader editor, I did set the right one. We can get the different attributes that we set. So I want to see what the split value looks like, first of all. I have a feeling that this is the wrong material. I set the wrong one. Yep, material 01. Back into the shader editor. Now we should see, as this progresses... Oh, splits. That's why I labeled it. There we go. Now we can see where the original particle was, which I did not expect it to be this one. Huh. So we can see split 1 happened over there, and then all the other splits after it. That is very interesting. I would not expect that. Huh. Not disappointed. That's very interesting. That's actually making me think about redoing the points, which I'm going to put the material 1 on this object, even though it doesn't really get considered, just so that I can swap between the shader and the simulation easily. So for the splits, I'm going to put this back into the randomization. Well, why did that start going down? Oh, that... Actually, yeah, why did that start going back down? Oh, right, because... Okay. That's no randomization starting out. Wait a minute. Oh, right, because that. Okay. So this is... Move away... And this is random. So random. There we go. Labeling those is... I should have done that before. So as we can see, these ones... The one that has no split, or... The original vertice is just happily going along, no edits to its random direction. But the more the splits happen, the more those occur. So we're visualizing the velocity. We're visualizing the data. There we go. And I think we should have more particles going off. There we go. I don't know why that one really dislikes spawning. Huh. Interesting. But if I change this back to the non-weighted probability, we'll see that it has absolutely no problem. Actually, no, it's still just... Maybe it's just because there's so many being spawned in there versus over there. Yeah. So we can see the difference there in that part of the visualization. Okay, let's reconnect this one so that we get more splits occurring. Let's see other data from this. Something is a bit wrong. I did increase the amount that would spawn in. Let's go back into the shader editor. Let's go over to here and let's look at the velocity. Let's put this into normalize so that it is brighter. Normalize. There we go. Let's take a look. So here we can see the actual offset data. Red, green, and blues. That's cool to see. But the one I want to see is the age parameter. There we go. So here we can see the age. Which, if I want to... Oh, right. The data that I want is the trail age. So I may need to implement a trail age value. Because here we can see, you know, the age over time, which will be good for, like, coloring and stuff like that. And we can also divide this by the lifetime, because we also have that parameter. There is no second capitalization in there. So if we divide those two pieces of data, we can see the gradient for the entire process. Once it hits 1, it's dead. So all kinds, we can have a color change for the whole thing, which may be preferable. We'll have to see. Like it changes from blue to like more of a pink or purple-ish. It's lightning. It's lightning. Right. But since this is a mesh, we also have access to the UV data for every single tile here, which will be good for texturing, because we can add the age to one of the gradients, and then it'll be a smooth gradient, which I'll showcase that a bit. There we go. And that's not looking quite as great. The splitting seems to be a bit high, so let me go and reduce that by a bit. 0.1. Is the randomization too high? Oh, well, yeah, that's... Let's change the randomization down. I just want to see. So here's just the splitting data. Just splits. What if I made it so that it's split first and then randomized? I think it may be better to split and then randomize, because we're mixing these. Now I could just add them together, but I like the mix factor a bit more. We really deviated from the lightning. Okay, I'm going to move this around so that the lightning... Yeah, let's just move around all the units so that I don't have to rename them. I like this kind of unit-based approach, because it's all blocks. You just move around the blocks if you don't like it. It's kind of like nodes, because it's all blocks. Blocks and lines. There we go. So now we have this, and I should label this bold velocity. Velocity. There we go. We are almost at an hour. And I'll be stopping at an hour, so I should probably get to the shading. Okay, so the randomization survives quite well. No matter how much they want to split, they'll still have the random value. So even if they 100% want to split away from each other, you can still control the random value. And I prefer that, if I'm being honest. Ooh, I like that little spin that did. Also, if I want the attraction force as well, we can do that. I like that. That could be, oh. That could be cool for a lightning effect as well. Oh, and I still have the randomization for the, scale. And actually, yeah, that spinning is because of the difference in speed. As we can see, if it all has the same speed, it just does that. But with this, some have to catch up, so they have to, or slow down. So they do the little spinny things, which I think looks phenomenal. If I increase the disparity between the speeds. Okay, that doesn't look quite as great. But it does look kind of cool, even so. Okay, so... what I wanted to add. Oh, right, we need trail age. So, because this is currently an instance, I'll store a named attribute, and actually, I should store it before the new stuff gets added. So that I'll start off with an age of 0. No, with the other one, I have the age happen the other way around. Okay. So I'll put... This needs to be on the instance domain, because every part of the trail is its own instance. So this will be age I for age instance. A named attribute. I'm making, like, serious facial expressions when emphasizing things, but you cannot see it. And I find that very funny. I just caught myself having a stern look while saying, be sure to do this. But maybe it's just... It helps with my acting, the way my voice carries on the live stream. But yeah, here is trail age. So, trail age. There we go. That's good. I think the music will be ending soon because it's only an hour. Alright, so back to the shader editor. Ignore the UV map right there. It's fine. It comes out as red because we don't have the selected object. Okay, whew. I've been talking a lot, so I've been getting just a wee bit lightheaded. So if we look at age I, and let's hide the unused sockets just to make this a lot more clean. Put them in frames. So if we look at the instance age, and make sure this is on the instancer domain, we can see that as the trail goes along, that happens. So if we make a greater than node, or in this case less than, we can see that those values are only where the new stuff occurs, which is very cool. Well, yeah, that's cool how that happens. But if we use a map range, let's see, 0, 1, or no, we want this at like 1 and 0, so there we go. So here we can have that occur, which it's not interpolated. It's only one for every single one because it's separated. You could join all of them together and then it would be fine, but that's more complicated, and I'm just doing this in the simplest way possible. You can interpolate it by just using the fractioned, or no, the UV map. You can get one of the gradients and then just use that to offset it by 1. Which I should probably showcase how to do that, just because we'll probably need it for this project. So if we separate the UV map, we can see that we can get the horizontal axis right here. Now if we add to here, and I may need to invert this, but we should have right here, no, that's the exact opposite of what we want, so maybe a subtract will be better. There we go. Yep, it's interpolating now. So that's how you do that. It'll happen automatically if you do like the extrude method, which in hindsight might have been a better method for this, but this is simpler visually because we just deal with where the particles go and then trail them after. Is it possible to make the velocity go along the tangent of a curve? Yes, it is. You just need to go and, actually, yeah, how would, okay. It's a bit difficult to do. No, it's not difficult. It's just, you need to do a bit of a workaround. Because, yeah, I'll showcase how to do it. We have time, for the time being. There we go. But we can just see that happening, which is pretty cool. Need to breathe. I keep forgetting to actually do the breathing part. Take a nice deep breaths. I'm going to slow down this to be like between 0.2 and 0.1. But I also want the ratio to be right, so I'll do like 0.05 because I like it catching up. No, let's keep it as is. Because I like that. That's cool. It's beautiful. Okay, so to make the particles go along like a curved tangent, let's add in just a circular curve. So here, let's just go to the points. And we'll need to bring in the curve. But the weird thing is, I don't think we can just sample a curve normally. Like if we use a sample nearest node, there's no curve for there. So we're going to have to convert this into points. So a curve to mesh, but we need to go and capture the curve tangent. It's annoying that this is the workaround, but it is what it is. So if we get the curve tangent, there we go, we capture that, and then, yeah, we capture that, and then we sample nearest, and then we need to sample index. These also sample index. These two got separated. They got split into these two nodes, which I do wish we still had the one node originally, because it just made things simpler. But yeah, curve tangent, there we go. And now we have the tangent of that curve. Let's just plug that into there to make sure we're right. And it looks like we are not. Oh, because we have to convert this. So, to mesh. Curve to mesh. So that's how you do it. It's a little annoying that it's a workaround, but we can see it is working as intended. There is the sample curve node, but that's just if you want to sample a certain position around the curve. There's no input position to sample from, which is annoying, but it is what it is. So this would take it, oh, at that part, actually wait, we use the length, it'll be, oh, 1 meter along the curve, sample that. But that's how you do it just normally. It's a little annoying, but it is what it is. Just how many, because here, as we can see, one workaround and then these two nodes being split up, which is, this is one of the worst case scenarios for inconvenience, I would say, because it, well, okay, maybe not the worst case, but you have to do one workaround so that you can go into these two split nodes, and you need to capture it beforehand. So with that all said, I hope that answers your question. And actually, these should go into an orbit, I think. Or maybe not. Yeah, they won't go into a true orbit because their velocity is not being accounted for with the sample position. Is there an inset node in 4.0? No, but in 3.6 you can make your own, well, you just extrude and then scale. I'll do this because it's so simple, but we need to get back on track kind of soon, because we're almost out of time. If you want to inset, it's very simple. Offset scale 0, and then scale elements. Just do that, and then boom, inset. No matter how many faces you have, it'll inset, or if you want it to be just separated ones, you do that. So, inset already exists. It's just two nodes, because the Blender devs don't want to add in like 100 specified nodes when they could be two more generalized nodes. I hope that answers your question. Because here you get a bit more control. It would be nice to have an inset node, but I think that'll be like for the asset browser and later on. And here you can decide, you know, how far out it goes. But unfortunately it's not uniform for uneven lengths, so I had to use a node group. Uniform for uneven lengths. Do you mean like face area? But yeah, you would have to use a node group. All of those more specialized nodes that could be done using, you know, like 2 or 3 nodes, those won't be implemented for a long time. Won't be implemented for a long time. Okay, lightning, let's get back on track. So this is a shader editor thing again. Let's implement lightning. So to do that, I'll use an emission. Like, if the plane is 2 by 1, the inset won't be uniform. Oh. Yeah, no. That's actually a good reason to have a dedicated inset node. But yeah, no, that doesn't exist. You should... I forget where, like, requests are, but that is a very good reason for a dedicated inset node. I would bring that up to the developers in the dedicated area for where suggestions are made. Be sure you find the appropriate place to put that, because the developers don't like it when you make suggestions in like the dev chat, which I've seen some people do. It's not recommended. But yeah, that's a very good reason. Okay, so for the shader, mixing transparent and emission. Whew. Okay, or let's use an add shader, just so that yeah, that's good. So we have that, but I'm going to use the map range and then a multiply to decide what parts get shown. So let's set this to like 20, so that only those parts get shown. And then another thing that you can do is use a power node to make the emission offset look better. So here we can see it's much softer. There's another way of doing that which is even better, but it takes more nodes, so I won't bore you with it. But here we can see just the trails going along. Now, I kind of want it so that we still see the originals, but they're not as bright as the others. So actually, yeah. I'm going to keep the endpoints as the brightest parts, but I'm going to add after the fact just for everything. This could be noise and other stuff, but it's good to see. There we go. So here we can see that happening. And we could have a more gradual trail for the other stuff. So in this case, we'll have a much more gradual trail until it fades to nothingness. And let's set that to smoother step. So it'll be between that and that. So this isn't lightning yet, but you can see the basics of it right now. We do that. And maybe just this. I do need to implement other things, like I don't want this harsh cutoff. Fortunately, we can fix that by using a ping pong node. We don't need that for the time being. So I just want the cross gradient. We use a ping pong. Ping pong. Yeah, we are 2 minutes away from an hour, so I need to wrap this up. So we have that, and then I'll use a map range to constrain the thing and make it better. Or no, simpler. Just multiply by 2 so that the middle gradient is the appropriate brightness. Now if we multiply the output by that, that means that the center will have the right kind of fade. Actually, wait, I need to do this before the power node. Or no, post. Post, it's fine. It's fine. I'm kind of pushing myself because of the time, but it's fine. That just makes it softer at the edges. And actually, map range would be better. Man, I'm really just going back and forth because of time constraints. Right-click select for future requests. Yes. That is a very good reason to have an inset node. Because of the uniform parts. Like, you could do that currently, but it would be a big headache with the amount of math that you have to do. So there's kind of lightning. Well, my stylized lightning because I got so distracted. But it looks cool! So, color ramp, you know, for the colors. And we are out of audio. Let me go back. Because it was 1 hour. That's a good timekeeper for me. When the audio runs out, it's time to stop dreaming. But there's a cool part, you know, let's switch this to like a hue saturation value. Clockwise, no, near. Hue saturation lightness, those don't really change too much. Yeah, cool things. Just... But yeah. For the lightning, I need to get at least one good lightning example here. So, yeah, lightning, 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 lightning. Let's bring this down by a bit, because I want the endpoints to be extremely bright compared to everything else. I think I can do that without, you know, changing the brightness to be ludicrously high. By simply making the ends completely white, and the other stuff, the blue. RGB. Yeah, so... Same blue, just not as saturated. And then, okay, maybe that was the right call. Eh, maybe both of them were. So here we have that. Look how bright that is. That, okay, that might have been a really good call right there. 82. Okay, and then you would have to put some noise on the bolt to make it look better. We have the UV maps for that. Like, you could have the age parameter. Yeah, actually, yeah. If we feed this into a noise texture, we should see that the noise shows up as intended, and you can use that to multiply. Man, this is getting bad. Okay, let me delete the everything else besides what's needed. We plug that in to the here we go, the map range for just the regular ad right there. Put that into a frame. Make the boxes just so that it becomes less of a headache. Control J. Smoother step. Put this between like that and that. There we go. Do that. Turn up the roughness. Turn down just the noise in general. Set this to be higher. Set that to be lower. Detail. There we go. That's not bad. Just could be better. And then one other side effect is that this texture, oh dang it, I'll need to have it to be the regular age, not the age I. I need to make sure that that gradient is right. Hello? Oh yeah, right. Geometry. There we go. And yeah, we need to make that an add instead of a subtract. Right? Need to make sure the texture is working properly. Yep, no, okay, it's working. Good. Now, there we go. The texture will just show up. Okay, that's alright. And if we want the texture to be random for every single split, we just need to add to here by the split value. But that means it'll be the... Ideally, you would have a random ID for every single split, or for every single particle, and then put that in there, which I currently do not have, but I'll add it in next time. Alright, so in summary, I need to get one good lightning like shot. So let me do that as the final thing. Is the texture is still not the way I want it to be, but I think it's okay for now. I mean, it's cool, but it's not saying the lightning to me. Maybe it just needs to be brighter. Just crank those up. And bring the other part down, constrain it. Like there, it's better. Alright, let's go back to the geometry nodes for the lightning points. Change this to be the separate. Actually, let's just turn that off. Change that to there. So now we can see. There we go. That happened. Nope, we still need the split. Kind of. So this wasn't the most productive effect. It was okay. Like, it kind of looks like lightning, but to be honest, I think the lightning generator I made before simulation nodes existed was still better. Like here we can see the, the parts that start out and all that, which is good, but still not great. This would need probably another hour's worth of like shader work to make it look good. Because I think when this was like 0 and 1, keeping that low, like we see this, I think that looks really cool. Maybe not maybe not lightning enough, but it looks really cool. It's 1, 2. No, 10. Yeah. So, I need to work on it more. I also think the noise is too infrequent. Or no, too frequent. Yeah. Then a fade or other things. Oh wait, no, I know what to do. I need to make it so that the value becomes more later on. Because I just remembered, this is why I need to re-look at the Thor Ragnarok reference. Because in the film, I remember the lightning got darker, and then got a lot brighter after the fact. So it was more like that. And actually, I can multiply that value. So, multiply by 1. So it's like that, and then got a lot brighter. So the initial kind of feelers went out, the lightning, those things, and then the bolts followed after. There we go, that's better. See, it just needed a bit more care and attention. And I need to look at the reference. Okay, more randomization. And more repel from your neighbor. That's cool. I like that. Maybe I can make it so that it repels, but then when it gets too far, it attracts. That would be interesting. Then here's it. Oh, that's cool. More randomization. Maybe like 0.1. Oh, that's cool. I like that. .5. Let's look from the top. Yeah, it looks more impressive like this. And more randomization. Now the randomization is diluting the other stuff. Maybe I should just add to all of this instead of... Well, I don't know. Blender is so complicated. Well, if you're watching this stream, I'm literally doing the most complicated thing in Blender, besides maybe rigging. That could be more complicated. But this is potentially the most complicated thing you can do in Blender. So, yes, it is very complicated. Because it's math. I'm literally doing my own custom, like, particle simulation. Yeah, I like that. Like, the colors need work. I think green would look better for this. Yeah. Then I'll just need to find the right settings. Because right now, the spaghetti is not exactly the best. How long have you used Blender for? On and off since I was a kid, so probably like 7 years. Maybe even 8 at this point. I got in early. Oh, that's cool. Just turns into complete spirals. But if it goes up too high, they just do. Then there's that. Oh, I like that. That's a nice one. Maybe I can just make the camera go and follow this. So it's just like, oh, it follows it as it goes through space. That could be cool. That'd be a good render. I like that. Alright. Thank you all for watching. I think this is where I end the stream. I don't know why it starts off with that orientation. I can make it so that starts off with a better initial velocity. So for initial velocity, we just store a named attribute initially over here, which I'll just make it up on the z-axis. So as we can see now, it's just doing its job, starting off right. I would like to put in depth of field, but because we're using alpha blend, it doesn't work. So, there we go. So we do that. I'll let the simulation play out. Now this is where I would turn on the cache, because, you know, it's pretty much done at this point. Do that, and let's extend that for even longer. And let's set this to linear. Maybe I should back up the camera. Yeah, and I don't like the texture. Like the noise, I think it'll look good if I change that up. We're going a bit over time, but it's fine. We're at, oh, already 1 hour and 15 minutes, so we're a little more than just a little bit over time. Change this, change this to 2 dimensions. Messing up my words, so that's how you know this is getting way too far along. So, do we need that? No, I don't think we do. Let's bring that back. Another thing that I could try is using the noise to affect the thickness of this. So here, as we can see, 0 and 0, but let's set that to 0.5. Oh no, wait, this needs to be 0.5 and 0. So about like that. Here we should see that the thickness of the beam is being affected by noise, which I think it's a little subtle at the moment. Let's make it a little more potent. Ah, there we go. So now you can see it. Oh yeah, the noise is way too high. Yikes. Yeah, that doesn't quite look the best because it does go to that. With the camera on a spline upwards while spinning around the lightning. Probably won't put it on a spline. I would probably have one empty to spin it in a 360-degree motion, and then one to move it up. Splines are a little harder to control. Am I doing this wrong? What's the right setting to, Yeah, no, that's right. So, did I have it on the right input? I think I did. I should probably have this at, like, 9.4, so that gets thinner, but not all the way to 0. Or all the way to 0.5. Something's still not right with the noise. If we do that... We got, 0.5. Yeah, I'll have to work on that. Like, at the moment, it's not bad. But it needs work, obviously. And I can also change the thickness of the trail up, and then constrain it using the shader. Let me get rid of that. I'm just going to do a little... Oh, that looks quite a bit better. Maybe just because I changed the size. All that. I could also make it so that the trail does follow it a little bit. But I would have to mix between the moving UV map and then the still UV map. This is the still UV map. So... Right, and that needs to be one dimension. So what is... The trail age. Okay, yeah. So if I add the trail age, or just... I could just move it using a value. So I could just have that happening. Which looks pretty cool. So I'll use a value node and input hashtag frame. Because the scene... And it's broken. Okay. So I don't know why this happens, but sometimes the the hashtag frame node just breaks. And I don't know why. It should be fine, but for some case it's going from 1 to 0. I have no idea why. It happens randomly, so I haven't been able to make a bug report. But for some reason it just decides to go back. See it in the driver editor. Okay, let's go and look in the... Open the driver editor. Yeah, for some reason, that happens. I don't know why. T linear? I don't get it. Scripted expression. Well, now that works. I don't know why. It's so weird. Well, okay, it's working now. Okay, let's use a divide so that it moves it a bit less. So there we go. You can see the trail happening. Very nice. Like, it would be very cool to have, that looks really cool. But I want to play around with the other colors. We are at 1 hour and 20 minutes. Okay. Ooh. Like, which color is the coolest? That's cool, that's cool. So many of them look so incredibly cool. think the noise is just a tad too frequent. Yeah, that looks better in my opinion. Okay, turn up the noise, turn up the roughness. Let's make it more like that, but that just makes it look like standard noise. Not exactly the good noise. That, it's okay, but yeah. And then I could also add in the other component to the UV map using a combine once again. And then just multiply this. I could just use a vector math multiply to change the X scale. But as we can see here, I would have to make this wider for it to work better. But I can do that. That we have more of that happening. Which I probably should just make this larger. Oh, and also, one thing I forgot. High contrast. Just makes it look cooler. Alright, that'll be all for today. Thank you all for watching. I'll switch this back to one dimension of noise, just so that we can get rid of a good amount of the confusing stuff. Thank you all for watching. This was a cool project. I want to add in depth of field, but I need to... depth of field... It doesn't work with alpha blend things, so I need to turn on jitter camera, but that takes a long time to resolve, so maybe I'll do that. Where is that? Viewport display, limits, there we go, okay. So there's that. Works, and I need to turn max size to 0 because that does the screen space blur, but I can't have that here. So here I would need to have some depth of field if I want that to occur. And maybe I'll add like some environmental particles around it to make it look cool. But for now, that's it. Thank you all for watching, and I will see you in the next live stream. This was fun. Alright, see ya.